Gratitude to our today guest, Engineer G. Anish Kumar, Director, Aadhyaa Skills and Research and Development. Welcome, sir. Now I request Dr. Kanchana Madam to introduce our guest. Kanchana Ma'am.
It's my pleasure to introduce our speaker, Mr. G. Anish Kumar. Mr. G. Anish Kumar is the Director of Aadhyaa Skills Research and Development, Chennai. He is LabVIEW training and certification expert. He has trained over 1,000. He has produced 50 plus CLD certified engineers and one CLA and CTD certified engineer. He has guided over 500 plus student projects. It's our pleasure to have you as a speaker, sir. We welcome you. Please take over the session. Thank you.
Thank you, sir, and thank you, ma'am. A very good morning to everyone. So I would like to thank Savita Engineering College as well as our department head and the faculty coordinator for arranging this wonderful skill enhancement webinar. Right. So for identifying this technology, so that which will be like useful for students' future. So for that itself, I should appreciate the department head as well as the coordinator. Right. So let me share my screen. So make sure I'm audible as well as my screen is visible. Kanchana ma'am, am I audible and make sure my screen is visible?
Yes, sir. Yes, sir.
Yeah. So dear students, so we are here for learning something about LabVIEW and its introduction. So you may wonder like, what is this LabVIEW? Why this webinar is given for us? We are from medical department, and we are engineers. So what is this LabVIEW specifically is going to do? So guys, this is Anish Kumar from Aadhyaa Skills Research and Development. I am here to introduce what is LabVIEW and its application. So through this, you are going to gear up your career, right? So, and we do have some certification program I do fill in the India. So let us introduce this LabVIEW. So why this LabVIEW is given to you and why we have met today, right? So this is about a discussion of career. So I know you're all engineering students, right? So why we learn anything to develop our career, right? So why we want to develop our career? We want a peaceful life, right? So everyone's mindset is to settle our own life, right? But you must clearly know what is this career, right? So career is an occupation undertaken for a significant period of a person's life and with opportunities for progress, right? If you do something for a long time, and if there is an opportunity for a progress, that means you are developing yourself. That is your career, right? So that's why you can see the people like cricketers say cricketing is a career, actor says acting is a career, and dancer and singer says that is their career, right? Because from the childhood or some long period of time, they spend a lot of effort to develop themselves. Right? They will keep on consistently working on their mistakes to strengthen themselves. Right? So that is care. Right? As an engineering student, you must take this engineering as a career because LabVIEW is a purely engineering tool. That's why we are here today. Right. So to know about this engineering tool, first you must know what is the career, and you must take engineering as your career. And if engineering is your career, first of all, you must know what is engineering. Right? Can anyone say what is engineering in a chat box? Even final year or third year, or anyone can say what is engineering, because we are all engineering students. Right. So if you ask anyone like what is engineering, the fundamental doubt starts from here. Right. From here, how can you become an engineer? It's definitely not possible. Right. First, you must know what is engineering. Right. Engineering is an application of science and math to solve a problem. Okay. Engineers figure out how things work and find practical uses for scientific discoveries. Meaning, engineers are problem solvers. Okay. Engineering is not a subject. Engineers are problem solvers. It's not your personal problem, it's not your friend's problem, it's not your home problem, it's a real world problem. So you are studying engineering to solve real world problem, right? So that is the main focus of engineering. It's not for CGPA, it's not for placements. So you are getting ready to solve real world problems, real world scenarios, right? But actually speaking, we are not doing that. So mindset of engineering student is to just complete this 4 years of course. So if you are seeing this engineering as a course, definitely we are not good engineers, right? So people says we don't get job in engineering. Movie says we don't get job in engineering, right? So all those, don't believe all those fake news, right? Our world is facing shortage of engineers. There are a lot more jobs. The world is facing shortage of quality engineers, right? But we don't have that quality engineers because of a few type of engineering students. Okay, so if you ask your friend or someone, a guy, why you join engineering? Okay, irrespective of any department. Okay, just ask someone why you join engineering. So most of the people can say, my parents forced me to join engineering. If someone is forcing you to do something, will you be interested in that? Will you be able to learn anything in that? Definitely not. So if you ask the same question, and few people may say, I joined here because of job security. Do you think you will get job by just studying engineering? Definitely no. And nowadays, this is the comedy, you know. Is this the job security? So just studying engineering, mark my word, just studying engineering will not give you job, right? So what you have to do, I'll tell you, right? And this is a innocent a third type of people according to me. Like why you joined engineering? I don't know. I don't have no other option. I want to get married with someone, so I need BTech or B behind my name. So if engineers are of this type, how the quality of engineers will be? Right? And next time, there are people who really wants to do engineering in the schooling itself. They'll decide, I want to study in IIT, NIT, MIT, or main Anna University, or this university. I want to do this department, this engineering. I want to do something. So there are people like you people, how you involved in this extra learning, eye-opening session, right? So likewise, there are some passionate engineering students. They can do well who's interested in exploring things, not just learning things. Right? So we cannot blame these type of students. There are so many type of students who's interested in studying, who's not at all interested in studying. So overall, we call them as engineers. Right? So just joining the course is not engineering. So keep it in your mind. Right? So this may be because of education system in our India. Right? Of course, 99.9 percentage people might have came across this word, like just complete 10th successful, then you will have a very good future. Of course, almost all of our parents used to say, because we'll be playing here and there, and parents used to say, just complete this 10th, you will be settled, right? Of course, you at the end of the year, so before the exam, you'll do something and you'll be learning something. So you'll think that okay, 10th completion of 10th will be like enough. Then later it comes, just complete 12th successfully. Then you'll have a very good future. Is it so? So we have completed 10th and 12th. Our life is not successful. Next, just complete graduation successfully. Then you'll have a very good future. Is it so? So mark these words, just complete, just completion. So with some extra force, you are just completing the things. It's not with your interest. That is the main thing. And finally, people used to say, like, just get a job successfully. After engineering, you must get a job. We are studying engineering for a job. No, right? So then you'll have a very good future. Is it so? If you get a job, will you able to be like a very good future? Not possible, right? But the truth is, you cannot build your better future with this normal mindset. Okay, so completion of something, that sake itself is not good mindset to do this engineering, right? So what you have to do to get a better life? Okay, so it's all about skills. So you must know the difference between knowledge and the skill. Knowing the thing, okay, so theoretically is knowledge. So if you know something how theoretically it works and you don't know practically how it works, right? So that is knowledge. You just know the theory, and when you could able to implement that, right, that becomes a skill, right? So we are here to develop a few skills here. So one of the skill is this: you have to improve your communication skill. Okay, so it may be any of your mother language, of any other language, okay, but you should speak properly. You should able to communicate properly, point to point, right? So you must be good at English nowadays. Just knowing the English itself will give you more job, right? If you're seeking for a job, right? Build your technical skills. Okay, so in universities there are a lot more laboratories will be available. After 5 o'clock, few laboratories will be available. So many clubs will be available. You can engage in all the clubs. You can engage in the competitions, project expos. So to do all these things, you must develop your technical skills. So what you are learning from the book, that will be implemented here. And maximum utilization of college resources and practical labs. That's what I said now. So there are so many laboratories. Those laboratories will have crores and crores investment just to make sure students are making use of that and learning that. Okay, not for showcase. Okay, so make use of all these college resources and the practical labs mainly. Right? I don't know how many of people will go to library first of all. Okay? And the main thing is learn at least 4 coding language. Okay, so you may think, wow, how many language should I learn? So learn at least 4 language. Make sure your life is better. Okay, so one of the best language will be our LabVIEW language.
Excuse me, sir. Speaker is on mute.
Okay, okay.
Excuse me, sir. Speaker is on
Thank
mute.
you. Now, yeah. So don't stick to domain. So I was telling that. So you may be from this department or that department or any department. So you come under engineer. So you are engineer. You must know part of electronics. You must know part of electrical, mechanical, biomedical, everything. So combination of department becomes engineer. So never stick to domain strictly. Next, don't stop learning. Once you stop learning, you start dying. This was said by Albert Einstein. So it's like, don't wait for someone to force you. Don't wait for someone to tell, okay, tomorrow is the exam. This is that. That is this. Okay, so don't have external influence with you, right? So start studying, start learning here, right? So here comes the LabVIEW, so National Instrument thing, right? So to redefine engineering, this National Instrument is an American-based company. They introduced software as well as hardware, and so many things are there. And that software is called as LabVIEW. So LabVIEW is not a language; it's a tool where engineers can interact with that, code with that, and program with that. Okay, and there are a lot more sensors available, biomedical sensors, and all department, all domain related sensors available. And there are so many hardwares, data acquisition hardwares, FPGA card, and so many things are there, right? So this is about a national instrument, and this national instrument is the inventor of LabVIEW. So LabVIEW, you can see here, build your future with LabVIEW. So this lab, a full form is like a lab is for laboratory, VI is for virtual instrument. Okay, laboratory, virtual instrument, EW is for engineer's workbench. So this tool is given for an engineer or research scholar, a scientist. So only these people will use this tool for automation and testing and measurement. Okay, there is no industry without automation, without testing, and without measurement. And due to this accuracy, as well as due to this easy coding technique, and most of the MNCs, Fortune companies are using this national instrument product as well as the hardware. Right? Even in the IT sector, okay, there are teams which works with this LabVIEW for automation testing and measurement. Even if it is Infosys or CTS or any IT company, there are teams who's using this LabVIEW. Right? And if you come to this core side, and almost top Fortune companies, almost many companies are using this LabVIEW. I'll show the list. Right. So the advantage of this, when to use, where to use, is like whenever we need accurate result, right, with less jitter, as well as whenever you want to automate something or measure something, you can make use of this LabVIEW. Right. So this NI's academic future, so how this National Instrument LabVIEW is playing a role in this industry side as well as in the academic side. So industry side, I already said you, it is mainly used for automation, testing, and measurement. And in academic side, to bridge the gap between the academic as well as the industry. So National Instrument plan to bring this LabVIEW to the academics. Right? Why? Because what is happening in academics? You learn theory, then you learn some simulations, and you learn some experimentation. Right? So theory is a general thing. Right? Regularly, you'll have 5 subjects, you'll be learning something, and you'll go for the exam. And simulation is a laboratory. So you'll go to a lab session and you'll do something. And few lab section only you will be like experimentation. So hands-on you will do. Right. So these are the books you learn. So you can learn all the theories from the books. Right. So example of some books here. And later we'll go with the simulation. So this is the step to learn. This is what involved in all the universities. Right? And software involved in engineering. I have mentioned a few here. There are so many softwares where you will just simulate the thing for better understanding. So making what you're learning, so bring that to simulation. So in simulation, identify the mistake and correct it, and then practically implement it. So this is the step. Right? And experimentation. The return to the era of Thomas Alva Edison. So in those period, there was so many hardwares, so many things. So there will be some theory. Directly, there will be like experimentation. Okay, there was no simulation in between in the olden era. Like only theory will be there. From that theory, they will build a product. They will try to build a product. There was no simulation. Right. So here comes the national instrument. So it made the process so simple. And as of now, this is just a simulation software. Right. So in the olden days, even our faculty and someone who learned engineering before 8 to 10 years, they might have seen all these things: function generator, oscilloscope, spectrum analyzer, DMM, power supply. So many things are there. Just to generate a single signal, sine wave signal, you have to use all these things. There will be a group of people, like one batch, 5 people will be there, and there will be one person who should bring all these uh, instruments to the bench. No, he don't know what is function generator. Everyone will be confused, like what is function generator, everything looks same, and what is DMM, what is oscilloscope, everything looks same. See, now it's everything looks same. So there was a lot more confusion to generate a sine wave. Then how engineers can innovate something, how engineers can learn something to avoid all these confusions, so to reduce your time. All those 12 or 20 instruments are put together, and National Instrument made a single device. We call that as LVIS. LVIS, right? So in this LVIS, there are so many versions like LVIS 1, 2, 2 plus 3, and so on. 3 is there. So with FPGA cards. Okay. So this consists of all these instruments. Oscilloscope is there, function generator is there, switching is there, generator is there, DMM is there, power supply is there, everything into a single box. Okay, so compact and portable so that wherever you go, you can even take it. Right? And there are so many hardware from National Instrument, which is just a lab inside your pocket. Okay, so those hardware will be the size of your mobile phone. So if you have a mobile phone in your right pocket, you can keep that lab in your left pocket, and you can sit anywhere and do your lab exercise, even under the tree. Okay, anywhere, in bus, okay, in train, in flight, wherever you are traveling, you can take that small hardware. We used to call that as MyDAC, MyRio, right? So just you can have that and you can do your experiments, and you cannot stop your learning, right? So nothing will interrupt you. That is the advantage of this NA hardware, technically speaking. Right? So here, experimental education result, I hear, I forget. You must accept this. No, if you hear something, definitely you will forget that, and if you see, you will remember. I do, I understand. Okay, I do, I understand. So starting, I was telling like if you just learn engineering, you will not get any job, you will not get any benefits. So what do you have to do? Don't just study engineering. You should start doing engineering. So there is a lot more difference in just studying and start doing engineering. Right? So gain the skill and start implementing, do the engineering. Right? Only then up to 90% of the thing, you can learn. And frankly speaking, engineers are visual learners. We all are visual learners. Right? For example, if you see any movie, you will not forget. You will never forget that. Right? If you see any ad, if you see anything with interest, you will never forget that. But if you see any questions in the book, definitely you will forget. Right? So we join together today just to do engineering. Stop studying engineering. Let's start doing engineering. Right? So this LabVIEW is a single platform for infinite solution. Again, you may get a doubt. Okay, LabVIEW. LabVIEW is a laboratory virtual instrument for engineers workbench. Okay, so that's going to be a tool. Okay, in that tool, what language we are going to use? So like C, C++, Java, in LabVIEW we use a language called as G language. This G language is nothing but graphical language. Right? So that G language is nothing but graphical language. So why this LabVIEW is reducing time, and what is the advantage of this LabVIEW? This is the best language to understand. This is the best language to implement your logic, whatever you are thinking in your mind, and you can just implement this. And mainly, this is not scripted language. So we are not going to a program like Ash include Studio.h, Ash include Conio.h, or else it's not like MATLAB scripted, right? This is going to be a drag and drop. I'll show you the demo, right? So this is about drag and drop. So get an idea. So where we have worked with the drag and drop in our childhood days, you know, uh, almost most of us might have used a paint, MS Paint, right? In that, if you want a perfect circle or perfect shape, what we'll do? Just we'll drag from the shapes, we'll drop it here, we'll resize that according to our need, right? So we call that as drag and drop. The same pattern is here, dragging and drop. Right? There is no commas, there is no apostrophes, there is no full stop, open brace, close brace. Nothing is needed. Right? And if you're expert in MATLAB, you can do MATLAB coding this LabVIEW. If you're expert in C, C++, you can even code that in this lab. And control systems, you can do this. And FPGA, you can do this. Right? Data acquisition, you can do this. Python, you can bring it here, and machine learning will do it here. So it's a single platform where you can implement any language. If you're expert in .NET, so anything, you can bring it here, and this will accept all language as a drag and drop. Okay, I'll show you that. And these are the few hardwares here: SVRIO, Compact Rio, PXI, and there are some academic hardwares that, as I said, lab inside your pocket. No, possible. I'll show that. So why you must learn this LabVIEW? As I already said, this is the tool. Okay, this is not the language. LabVIEW is the tool. Only scientists will use that, research scholars will use that, as well as the engineers will use that. Right. So as an engineering students, why you must learn this is to do your own project. Right. Instead of going to project center and doing something else, learn the subject and try to implement that and do your own projects. Right. And using your LabVIEW, you can do your engineering projects. Right. And you can do some research projects for patent rights. Right. You can publish a journal, IEEE journal. So it doesn't mean a third year should not publish any paper. So from the second year, you should start publishing some papers in the journals, and you should go for a paper presentation. Right. So if you're good with technical skills, obviously you'll go with all these things. And there are so many funded projects. Okay. There are government funded projects. And as engineers, you can join with your MTech students and do their projects. You can join with your PhD professors and you can do your projects. Right? You will learn more if you join someone who is in higher grade with you. Right? So it doesn't mean that only after knowing this LabVIEW you can enroll in all these things. So LabVIEW or any technical thing is like exploring the thing. So your interest is needed, exploring is needed, and step by step, daily at least 1% you can learn it. And this LabVIEW is as easy as that to learn on your own, right? So definitely you'll get this doubt. How do I innovate? Because engineers are to solve the problems. We are here to innovate something, right? So in day-to-day life, we are facing so many problems, right? Technically speaking, and you can innovate something to overcome that. So now there is nothing to overcome this pandemic. So next pandemic again is coming back. So likewise, what we can do, how we can save our life, and as an engineer, what is your role to solve this environmental issue? Are you thinking about solving this issue? So we should not think like someone will do it, or this government will do it, or some doctor will do it from some other country will do it. No, even a first year student can think how we can solve this current environmental problem, right? So this world problem, even a first year student can think and come up with a solution. We can approach. So think on solving the real time problems, right? And that's why this was chosen by these many top fortune companies. So I'll show this slide for a while, for a minute. Okay. So HP is using, Siemens is using, Motorola using, Yokogawa, and some of the companies are missing here. So in slide I have mentioned only few. Right? Nissan is using, Boeing is using, NASA. You might have heard about Tesla. You might have heard about SpaceX, Skylink. So all these companies are using this LabVIEW because of its accuracy and less time consumption. And this is, as I say, it's an engineering tool to simulate, test, and measure and automate. Right? And Ford. Right? So these are the very top companies, right? And how they will recruit is like you must know basics of LabVIEW and you must be certified. Okay. This national instrument is having only three certification for engineers. Okay. So the first one is associate developer, the second one is LabVIEW developer, and the third one is LabVIEW architect. Okay, LabVIEW architect. So only three levels. It's like beginners level, intermediate level, and the expert level. Right. So the starting level is associate developer. This associate developer is like knowing the tool, how this LabVIEW works, knowing the tool and doing your mini projects, right? So up to that is your associate developer, and the developer is if you could able to do a major project, okay, so then you can be a developer. And architect is about the experience. So architect is about experience, 3 years of experience, how well you do develop a code. So based on that, get an architect. And we have a certification a program as well as certification exam conducted by National Instrument. Okay, so these are a global certification. This is not only valid in India, this is valid everywhere. Okay, throughout any countries. You can go for MS for America or UK or anywhere. You can do a part-time job or anything, right? This global certifications will be accepted, right? Frankly speaking, in our regular placements, if you have something different in your resume, like you can use this logo in your resume, you can engage your HR by definitely they'll ask what is this lab. You can engage the HR to get the job, right? Only if you are interested and confident enough about that tool or anything else, right? So this certification plays a major role. This is the global certification triangle. Like first one is CLAD, associate developer, and second one is developer, and third one is architect. And we do have one more certification that is embedded system developer. That is domain specific certification. So only after CLD you can do that CLE and CLE. Right. So these are the things available in national instruments, right? And some research labs are also using this lab, right? So ISRO is using, DRDO is using, and just have a look at it. So guys, you can even take a screenshot of this, and you can search all these research labs, and you can even search why they are using, for what purpose. So I'm not saying completely they are using only lab. No. So they are using LabVIEW as a part. So LabVIEW is having some strength. Okay. So only in that area they will use it. Okay. So that's why I said all Fortune companies will have LabVIEW for its accuracy and its simplicity. Right? You won't take a screenshot of research labs. And once you get a job in ISRO or DRDO, just think about it. Think its facility. You'll become a real scientist, a real engineer. Right? So just going with IT job is not that much recommended. Okay? So let us kickstart a basic. So I was telling about LabVIEW, LabVIEW, LabVIEW without showing the tool. You may think, right? So LabVIEW tool will be like this. Okay, so I'll just show. So this is our LabVIEW tool. Right. So once you open LabVIEW, I'm using LabVIEW 2020 version. There are so many versions. Okay, even upgraded versions are available. So what I'm using currently is the 2020 version. Right. So excuse me. So I'll show one demo here. So temperature monitoring system. Okay. So kind of temperature alert, right? You may use some temperature sensor to check the body temperature or some other temperature. So you can set an alert system. Right? So if your temperature is above some threshold value, you can indicate that with overheat or something. If you are finding a fever, or also due to COVID, if the body temperature is high, right? So this kind of projects can help you to find by seeing itself. If person is in front of you, and we can set a project, okay. By seeing the person itself, you must know whether the temperature is high or low. whether he is vaccinated or not. Right? There are some project ideas, instead of doing COVID test and all. So once he is vaccinated, we must know he is vaccinated or not. So let me first introduce you about the tool, right? So unlike other language, this is G language, I said. So G language is a graphical language. So this is graphical programming language, right? And once you open this tool, you can see there are two windows. Okay, so left side I have one window, and right side I have another window. Right. So we call this as front panel. So you can see it here. So we call this as front panel, and we call this as block diagram. Okay. So since this is an introduction to LabVIEW, so beginners be careful, right? So who is experienced with LabVIEW, you may feel like this is so simple, but for the beginners, watch it carefully, right? So we have two panels here. Okay. So remaining software, if you go with that, all will have a single panel to run or to compile the program. Okay, so in LabVIEW we have two things here. So one is with gray check, the another one is with just a blank one. Okay, white space. Okay, this is front panel and this is block diagram. This front panel is for inputs and outputs. Okay, so inputs and outputs. Okay, generally we used to call something as input and output. Right. So we can keep only input and output here. In LabVIEW terms, all the inputs are called as controls. So in LabVIEW, all the inputs are called as controls. All the outputs are called as indicators. So here we won't tell it as a input or output. We used to tell this as a controls and indicators. Right. So like what is controller and what is indicator? If user is interacting with something, okay, to give a value or to change the value or to some interaction, so that is called as controls. You know about inputs, right? So that is called as controls. So what is indicator? If something is representing us, if something is indicating us, we call those things as indicator. Okay, and this controls and indicators will be kept only in the front panel. Okay, so why? Because if you just look around your room, you can see a fan, you can see switchboard, you can see the monitor, right? If you see all these things, switch is a control and fan is the indicator. Switch is the control and tube light is the indicator, right? So only these things are available in your wall around you. But can you able to see the wire connections behind that? No, those wire connections will be coming behind the wall or inside the wall. Right. So those circuit connections will be programmed in this block diagram. Okay. So this is for only controls and indicators, as you can see switchboard as well as the fan or tube light. This block diagram is for connection, wire connections or circuit connections, which is inside the wall. Right. So now let me show a small program. Like I would like to add two number. So I'll take one numeric controller. Right. So when I place this controller here, automatically I'll get that controller in this block diagram. Okay. Next, again, I'm right clicking here. You can see so many controls here. So we call this as controls palette. So if you right click front panel, you can take all the inputs and outputs. That is controls and indicators. Right. So if I go with numeric, I can see all type of numeric controllers and numeric indicators. Okay, if I go with Boolean, I can see all type of Boolean controllers and indicators. Right, all type of Boolean. Excuse me, Ma. Yeah. So this is Boolean, and we do have string controller and indicator, string controller and indicator. So if you take any project, definitely the basic three data types will be available. One is string, another one is Boolean, another one is numerics. Right. So what I will do, I'll take one more numeric here, and I will choose anything. You can choose anything. So I'll go with horizontal pointer slide. Okay. So you can just maximize it or minimize it, and you can do anything here. So that's why I say this is about dragging and dropping. See, I right clicked, I want some controllers, I'm clicking that and dropping. So we call this as drag and drop. Okay, and you can even change the scale. Now the maximum scale is 10, you can even change the scale to 50 or 100. So automatically it will auto scale. Right. Suppose I want to add two numbers. We'll go with the deep basics. So I want to add two numbers. Okay. So I have two controllers so that I can give some values here. I will just adjust this line. Okay. So now I want to add two number. So to add two number, we need some logics. Okay. So C equal to A plus B, that kind of logics we need. But this is LabVIEW. Right, this is about drag and drop. Okay, so if I right click on my front panel, definitely I'm not going to get any logics. I'll get only controls and indicators. To get the logics, you have to right click on your block diagram. So once you right click on your block diagram, we call this as functions palette. So in this functions palette, there will be so many logics, inbuilt programs. You no need to program anything. Everything is inbuilt one. Right, so I want to add two numbers. So number means numeric, so I'm just moving my cursor to numeric because I'm going to work with the number. Okay, so if you're going to work with Boolean, just move your cursor to Boolean, so all logic gates are available here. So likewise, if you move to string, related to that string you will get all the values. Right. So now we are going to just add two numbers. So I'm going to numeric. It is showing all the arithmetic functions. Right. All the arithmetic functions. Okay. So let me take this add, drag, and drop. And I would like to label this one. So I can right click that, visible items, and label. Okay. So now I have two controls. I have one function. We call this as function, or you can call this as a logic. As a beginner, you can call this as a logic, but actually speaking, this is a function. Okay, and what else we need? We need one indicator. So to get an indicator, I must right click on front panel or block diagram. So block diagram will give only functions, only front panel is going to give controller or indicator. So now I need indicator, right? And it's going to give the output as a number. So I'm going to numeric, and I can take any of these indicators, anything. Now I'll take this one as an indicator, and I'll change the scale to 100. Right, you can maximize to any size, and you can move anywhere, and you can rescale it. Right, so I'll keep it here. Okay, so now only one thing is pending, that is a wire connection. Okay, see here, this is not scripting, right? It's about a drag and drop and just going with the logic. That's what I said before. So see here, if you zoom it here, you can see a small arrow mark towards your right side. Here, as well as in this control, you can see a small arrow mark. Right? So the meaning of that is it is ready to give the input. Okay, so because in LabVIEW the data flow will be from right to left. Okay, so in LabVIEW the data flow will be from right to left. So that's why we'll just connect the wire from left to right. Okay, so the data flow will be always from left to right. So that's why we'll connect from left and we'll connect to right, and from left to right, and from left to right. And see, in this indicator you can see on arrow mark in the left side. Okay, it means it is ready to accept the data. Okay, so these two are ready to send the data and this is ready to accept the data. Okay, that's why the arrow marks are given like that. So you can identify which is controller, because if it is given like this you must able to identify which is controller and which is indicator. Okay, so only by these arrow marks you can find which is controller and indicator, right? And wiring is also so simple. I will rewire again, deleting these wires. Okay, you can see my cursor like a +1. As I go near you can see the change in the tool. Okay, so now this is plus. As I go near this arrow mark you can see kind of bundle. Okay, so that is called wiring tool. If that bundle appears, just left click, drag it, and again come here. This addition point is blinking. If it is difficult to see, just zoom it. Okay, this point will be like blinking, and connect it. Okay, even I will try to show. Okay, I will try to show you. See here, see my cursor. So now it is plus, and as I go with this arrow mark, just change it to bundle, and this is wiring tool, and clicking and left click, drag, and as I move here it is starting blinking. Okay, so it will start to blink, it means it is ready to accept it. So just drop it. Okay, drag and drop. So you can move the wire anywhere, so you can play with this. Right, so that's all, our program is done. So addition of two number is done. So we need two controls, one indicators, one function, just wire it. It's all done. No need to think about what is C, no need to think about what is what, comma, apostrophe, and all. So you can rename this like double clicking A, double clicking B, double clicking. Okay, as simple as that. And give some lucky numbers, and you can even slide it. Okay, so now this should show the output. Right, so now after that our program is not completed, not yet completed, so you must know about these tools. Okay, now controls are ready, indicator is ready, or function is done. So how to run this program, how to compile this program? So instead of compiling we have an arrow mark here, this is run. Okay, execute the program, compile the program. Okay, so in LabVIEW we call that as run, and another one is there, that is continuous run. Okay, so continuously execution of the same code is called continuous run. And we have one abort function. So abort function is to stop, interrupt the program. Okay, so next one is pass. So of course you know about pass, so it will pass the program and again you can resume it. Okay, and these things are like object alignments. Okay, suppose I want to align these tools. Okay, I can align it. So I can maintain the same line, or you can align, you can design your front panel, right? All these are alignment tools. Okay, so I'll show one more thing. When I right click my front panel, you can see some decorations here. Okay, so in this there are a few just like frames. You can take something. You can drag it. Okay. So as I placed on top of my controls and indicators, my controls and indicators are not visible. So what I must do is like select this one, and there is a last function. We call that as a reorder. So in this, we can choose this option, move to back. Okay. So I'll repeat my steps. You can right click your front panel. You can go with this decoration panel. Okay, so you can take anything, whatever you want from here. Okay, you can take anything, just drop it and drag it. And if suppose if that is overlapping any of your controllers or indicators, you can select that one. You can just reorder, so you can make sure this decoration thing is going back like a Photoshop or something. Okay, so now this looks like some instrument. Okay, we can even type the title here. Okay, for example, if this is your title, you can keep it here. Right. So now everything is done. You know about single run and continuous run. See, I'm running the program. Right. So as I ran, see the output. Okay, so this knob is showing some value which is not so much that much clear. So what happened, we do have another option, like you can select this one. You can select this one, visible items. There is something called as digital display. Right? So this digital display is available for all the controllers. Okay, for these two. Right. So using that, you can accurately see what is the value coming out. I'll change and run. It will show some values. I'll change and run. Okay. So instead of changing and running and changing and running, I can go with this continuous run. So I'm running continuously. So as I move the slide, the output will respond. So we made this as easy as possible. Right. So suppose if I change any values here, it will respond. So that is the use of continuous run. Okay, so this is again, it's a virtual instrument. You can design any instrument using this. Right. So now let us do one small temperature monitoring system. Okay. So to temperature monitoring system, what we can do is like we need a numeric. Okay. So we'll take one numeric to know what is the temperature. We'll use some boolean to check whether that is above the threshold value or not. And we'll use string to check whether the condition temperature is normal or some alert system we can do it. Okay, so see guys, again this is just a demo, so I'm going with the basic program. Right, watch it carefully, and if you have any doubt, you can just message here. So I'm seeing the chat too here. Okay, so I'll go with numeric because we're going to use some temperature sensor, assume like a temperature sensor, right? So here we have a thermometer. So drag and drop, and this is so tiny, so I'm just expanding. So you can expand as per your wish. I'm expanding, right? So by seeing this arrow mark, can anyone say this is a controller or indicator? Right? Yeah. So arrow mark is on your left side, so it means it is ready to accept the data. So if it is ready to accept the data, it means it is indicator. Okay. So this is going to show some temperature here. So the temperature is nothing but a numeric. Okay, so now what else we need? We need one alert system. So I'll take one square LED, right? So in Boolean, we have two LEDs. One is round LED, another one is square LED, remaining things are buttons. Right. So I'll take square LED, I'll rename this as temp alert. Okay, so again, I want to display the alert message. So I'll go with this string control or string indicator. We need an indicator. Right, we no need string controller because this panel is going to be a monitoring system, temperature monitoring system. So the monitoring system is going to give us the indications, right? So I'll take string indicator. So you can resize. Okay, so I'll give the title temperature. Right, you can maximize it and see. Now I'm going to decorate my front panel. I'll keep it like this. Simply I'm going to decorate it and I'm going to select it, reorder, go to back. Right. Again, I'm going to take one more decoration thing. You can take anything. Right? I want to cover this one. I'll take it, I'll cover it, I'll select it, reorder, go to back. And if you want to do further, then simply play with this. And this is not overlapping any of my controls or indicators. Right. So I don't want to do this reorder. This is not a disturbing. This frame is not disturbing. Again, I'll show. This frame is not going to disturb my code. I mean, my front panel objects. So no need to reorder. If something is disturbing, then you can use that reorder. So this makes your front panel like more interactive, like instrument, almost like a good instrument, right? So something you can decorate like this and let us program. See, I have thermometer and Boolean alert as well as the string indicator, right? Uh, So now we are going to code it. So now we are going to think whether the temperature sensor is going to be a random one, like a temperature sensor, or linearly we are going to increase the temperature. So I assume, so linearly we are going to increase the temperature, right? So for that linear increase, I'm going to use some loop, okay? Some loop concept. So there is a loop concept under which a for loop and while loop will come. So just coding language, right? And this concept, this programming concept is same for any other languages. The logics and the concepts you are learning here is same in Python or C, C++, Java or any other language. The concept, everything is same, but implementation method alone will change. There we have to script your logic. Here we have to drag and drop our logic. There everything you have to create it. Here everything is ready made. Just arrange them in a proper order. Right? It's kind of a puzzle. Arrange everything in a proper order. You will get the result. Whereas in other language you have to create the logic. Right? Now, so for loop and while loop. So when to use for loop and when to use while loop. Okay. So for loop, when we will use, if you know number of times, okay, if you already know, I'm going to run it for 100 times. Already, if you know my biscuit packet is going to have 10 biscuits. Already, if you know I'm going to produce 10 products or 20 products. If you know the number before starting the mission, then you can go with the for loop. Okay. So while loop is like you don't know how many products it will produce, but morning 9 o'clock I'll switch it on, and night at 10 o'clock I'll switch it off. It can produce any number of products. Okay. So until the condition satisfied, if you want to work with anything, okay, that is while loop. Right. So now for linear increase, I'm going with for loop because see my thermometer, the maximum scaling is 100. So what I'm going to do is slowly I'm going to increase the value from 0 to 100 and I'm going to check the alert system. Right, slowly I'm going to linearly increase. So that is the only reason I'm going with this for loop. Okay. So if your indicators, if you want your indicators to respond for this loop action, okay, so those must be kept inside the loop. Okay, if you keep it outside the loop, what happens? This will run only once. Okay, if you keep that inside the loop, it will execute for a known number of times or unknown number of times. Okay, so in for loop, there are two important things. One is n, another one is I. So n means I will create on a constant here. So n means how many times you want to run. Okay, so 0 to 100 is 101 times. So I'll go with 101 because from 0, right? And in for loop, you know, there is n and there is I. You might have heard like I equal to I plus plus or something related to that. Okay, so this is for. Okay, so this I always starts from 0 by default. It will start from 0, right? If you know about for loop, it's fine. If you don't know about for loop, just listen here. Okay, this n is the person you're going to say I want to execute this loop for 101 times. So he is responsible for that. Okay, but this guy iteration is sitting inside the loop. This is not outside the loop, this is inside the loop. Okay, he is inside the loop. So what he will do is like he will check. Okay, he will cross check n how many times it is executing. Okay, it's like you are saying run it for 101 time. That is not enough. It is having one more person who will check how many times it is executing. That is called as iteration time. Okay, so now let me directly connect. That's all. Simple. Take I, directly connect, because I is going to count how many times loop is going to run. So visually I will show, and you can, this I can be anywhere. Just to make sure the program is neat, I'm bringing this I here. Okay, so now I'm going to run the program. Let me make this to 0 and watch carefully. I have not connected anything here. Okay, I just connected I to this thermometer and going to run it. So as I run, see, my thermometer from 0 it went to 100. That's all. Our coding is so simple, right? But this is virtual instrument, and if you want to control the speed of increase in temperature, right? If you want to add some delay, right? If you want to control it, there is one more option called as timing. Okay, so in timing we have so many timing functions. In that I will use wait function, wait ms. So this ms is nothing but milliseconds, right? I'm taking this and keeping at this right up corner so that it won't affect our program, right? I created one constant here. Since that is milliseconds, I'm going to give some 200 milliseconds delay. So what happened for every iteration? So we are going to run the same code for 101 times. Okay, so for every iteration, it's going to take a delay of 200 milliseconds. Okay, it's not 200 seconds, it's milliseconds. Right, now we have added a delay in our block diagram. So see, right, there is a small increase. There is a delay in increasing in temperature. Right, so I think this is too slow. Let me reduce the number. Right, and you may have a doubt here. Also run continuous run is there, here also run continuous run, about everything is there, and alignment, everything. So where I must run it, here or here? You know, as a developer, if you are a coding as a developer, you know, front panel is fixed, but logics you have to code. So while building a logic, we will use only front panel. Okay, so sorry, block diagram, right? So we will be working here to debug it. Like if I give this highlight execution, you can see the data flow here. So this is for debug. This will be helpful for debugging your program, right? So you can see the data flow. So now 38 iteration is going on, and here 100 milliseconds. So you can visually see what is the data flow, right? And you can run here or there, the both the side you can run it. Right? Both are same. And if you are developing a code and if you are giving to someone else, or if you are selling this project to someone else, we won't show the code. Okay, we'll show only the front panel, right? If you're a program, if you're a developer and if you are giving this product to someone else, to some consumer, so assume like your telephone, I mean mobile phone or your laptop, you can't see any logics behind that. Okay, so only the front panel is shown. Your mobile display will be there, power button will be there, charging port will be there, and audio jack will be there, and the volume buttons will be there. You can't see the motherboard directly, right? Because that is their secret. So likewise, our code is our secret. We won't show our block diagram to anyone else. So the customer will give only the front panel, like your mobile phone and laptops, right? So the customer can only access to this front panel, so that they can run it here, they can continuously run it here, or they can stop it here. Okay, but if you're a developer, if you want to do some changes in the code in the future, or if you want to debug that, and we will work only here, right? So that is the reason we have run button in both the panels. Okay, so now we have achieved the temperature increase. Now let us go with the alert system. Okay, so now maximum temperature is 100. So what we can do is, like, if temperature is above 80, okay, if temperature is above 80, I want this LED to be on. Okay, so the condition, if the temperature is above to 80, it means we are comparing that with some value. We are comparing this input value to some constant value, which is 80, right? So I need a logic here. I'm right clicking my block diagram, and there is one more option called as comparison palette. Okay, this is comparison palette, and we have so many comparison functions here, right? So as of now, what I need is greater than or equal to. Okay, simply you can take anything, right? As per my logic, I'm going to take greater than or equal to, right? So I'm connecting this input value to the first terminal. Okay, so if my input value is greater than or equal to 80, so 80 is fixed. Okay, so 80 is fixed, so I need a constant. I will go with the numeric, so because that is numeric constant, right? So I can go directly to numeric. I can take a constant here, or else you can directly right click this terminal, and you can create constant, or you can create control, right? Or you can create some indicators too, right? Now I need a constant because 80 is fixed. Okay, and always the output of comparison palette will be in boolean. Like, just practically check it. If you compare anything, definitely the answer is going to be yes, no, right, true, false. Okay, so all the comparison, if you want to convert any data type to boolean data type, you can go with comparison palette, because always the output of comparison palette will be in boolean, yes or no. Right, now let us check our numeric is working, and now let us check this boolean. Okay, after 80, check whether this LED is on, and you can even customize this LED. So I'm right clicking this LED and going to properties. So we can choose our on color and off color. So this is alert system. So on color I'll go with red, and off color I'll go with some blue. I got your mind voice. I'll go with blue. Right. So let us check it. So if it is above, it should turn to red. Right. This is automation. Now you have programmed something, you have set everything for that program, and if that is achieved automatically, we call that as automation, right? Okay. So now our LED is also working. Now I want to display a message. Okay, normal temperature or overheat or something, or else message itself is alert. Okay, so now I want to send a message to this indicator based on this condition. Okay, based on this condition. Okay, so I must need this condition to display a message, and there is one function in strings, so in comparison palette. Okay, it is called as select switch. Okay, in comparison, because based on that value only we are going to display a message. Okay, normal message or alert message, right? So we are going to compare that value. So I came to comparison palette, and that function name is select. So this select function particularly works based on a condition, right? I'll use control H. So control H is a help window where you can see ESF. So first terminal is true, second terminal is yes, that means condition, and third terminal is false. So if it is green color, that means a boolean. If it is boolean, there will be only two states. One is true, another one is false. Okay. If your condition is true, whatever you are programmed in the top terminal will be coming out. If your condition is false, whatever you have programmed in the bottom terminal will be coming out. Right. So we need two conditions, two messages. So what I'll do, I'll go with string. I'll take one string constant. Right. Let us make that as a alert message over heat. Okay. I'll take one more string constant. I'll name this as normal. Normal temperature. Right. And in true side, I'll give this overheat. In false side, I'll give this normal temperature, and a middle green color is a condition, right? So condition we will take from here. We can reuse our code. Okay. So if it is above 80, then LED will be on, it means true. If it is true, it means overheat. Okay. Until 80, it is going to be in false state. If it is false, it is going to display normal temperature, right? I'm connecting this, and I'll select all the indicators. I'm going to reorder this. I mean, arrange this to my left side. So the program looks somewhat neat and better, right? So that's all. Our simple mini project is ready within a minute, right? I'm going to run the code. So temperature is blue color, alert system is normal temperature. If it is above 80, it's overheat, as well as the LED is clear. So likewise, you can do so many things in this, you know. So there are so many domains you can work with. You can work with image processing. You're from biomedical department, right? So you must know about the electronics as well as image process. So based on this vision, you can do cancer cell detection, or so many tumor detection, or based on the image, you can do plenty of things in healthcare system. Okay, healthcare departments. Okay, right? And there are so many signal processing thing. Right, I'll show one by one. Right. So you can use the data acquisition. So one hardware I used to say. So this NI DAC MX is the tool which is used for my DAC or CDAC. There is a hardware where you can physically interface the sensor. See guys, now I just used this thermometer, and from iteration terminal we are giving the value. Okay, so from iteration terminal I'm directly giving the value. Right. Instead of this, practically speaking, we'll use some sensor. Okay, temperature sensor. Right. So temperature sensor is going to give you some random values. Okay. In the numeric, we do have some random number function. Okay. So let us assume this as random number. Okay. So this is random number sensor, right? Let us assume this will give some random number, you know. So this is going to give only from 0 to 1. So that is how this function is designed. We can increase the scale by multiplying it. So simple. So if you want to increase the scale from 0 to 100, I will multiply with 100. Right? If you want to scale to 1000 or 50, whatever it is, okay, So you can just multiply that maximum value so that 0 into 100 is 0. So range stays with 0, and 1 into 100 is 100. So the range will be between 0 to 100. If you multiply with 10, the range remains with 0 to 10. Right. Now I'm going to connect this here. Okay. So now it's going to be a random one. It is not going to increase linearly. Right. Let us check it. Now this is going to be a random one. Okay. So you can also check how many times it achieved the peak, how many times the temperature increased above 80. So likewise, you can even have a separate thing, right? At which iteration, what is the maximum temperature you got, right? In the random number, so whether you got the maximum temperature or not. So everything you can find it. I'm just arranging my code. Right. So why I used this random number is like because of sensor. Okay. So our temperature sensor is going to give some random temperature on it. So based on the environmental condition or based on its atmospheric temperature, so the temperature is going to vary. That's why I used this random number as a sensor. Okay. So to be very frank, the hardware program itself is the same. Okay. For the same program, if you just interface the sensor and the hardware, and if you choose the channel here, okay, somewhere, the same program will work. Okay, so there won't be separate program for hardware. There is no separate program for software. No. So whatever you are doing is a simulation. Instead of that, you can interface real LED. You can interface LCD display, real display, and you can even interface a real thermometer to visually show the values, right? But code is same. You don't need to change anything here. Only the pin configurations, so which terminal you have connected LED, which terminal you have connected your thermometer, which terminal you have connected your display, so only that varies, right? So next, with while loop. So with for loop I have showed one demo. So now with while loop I'll show one more demo. So this is a while loop, take a drag and drop. Okay, so this is the condition term. Okay, for for loop we saw two things. One is n, another one is I. Okay, n is the loop count, how many times you want to run the loop. I want how many times you want to execute the program. And iteration is the terminal which will count how many times your loop is running. The thing is, it will start counting from 0. 0 also is a count. Okay, so likewise in while loop, again instead of n we have one thing called as condition terminal. Okay, so as I said, if you don't know the number, I mean, if you don't know when this temperature will reach above 100, maybe it may take 1 hour, or it may take 1 week, or it may take 1 month even. Okay, so if you're not sure about when that will occur or when that will happen, right, then you can go with this while loop. So when the condition satisfies, stop the program. When the condition satisfies, do this one, do that one. So you can instruct the application, you can make that as an automation, right? So and you can see this green color again, I said the green color, if you take anything in green color, see, boolean controller is in green color, boolean indicator is in green color, right? So all these green colors are nothing but the boolean, yes or no, right? So likewise, see this condition terminal, this is also having some green color. So it means it is going to be a yes or no. So I'm going to create one control, right? As I create control, I'm getting one stop button. You can maximize it as per your interest, and I will label it, this is while loop, right? So while loop is always for a continuous process until the condition satisfies. So for loop will not run for the whole day. It will run only for the number of times you have mentioned. But while loop will run for a day or month until unless you are stopping it. It means, technically speaking, until unless the condition is satisfying, the while loop is going to exit. See guys, again, the logic is same for any coding language. Only the implementation method is different. Okay, so this is while loop, and what we can do here is like I'm going to generate a signal. Right? So to view a signal, we need one indicator. So in numeric, we cannot see the signal. We can see the values, but we cannot see the signal. In Boolean, of course, this is just about LED and switches. And string, we can see the message, but not the signal, right? So for that, to overcome that, we have a graph palette. In this graph, we have a waveform chart, waveform graph, XY graph. So XY graph is for the 3 dimensions, and you can see 3D pictures, right? So there are so many facilities available here, right? So use charts now. Okay, so this is one style of chart, and I'll show another style of chart. Both are same, but style will be different. So right click your friend panel. So instead of taking graphs and chart from here, you can go with silver. Okay, silver in graphs and chart, and I'll take a chart. This looks somewhat different, customized one, that's all. So both are chart, it is customized. Silver is customized, and this one is the default one. If you are getting any phone or a laptop, will have default screensaver. No, so this is that the default one, and the second one is like somewhat customized, like applying themes. Okay, so both are same. I'm going to use both, right? And first, let me use one random number. Let me see some noise signal. Okay, so I'll take a random number, and its range is from 0 to 1. And of course, now it doesn't matter. I'm just going to see how this chart is going to work. Okay, I gave a normal connection, and if it is a loop, of course we have to introduce the timing here. So I'll use wait timing here, and I'll label this one, and I'll connect it. And this time I'll give a minimum delay. Just 100 millisecond is more than enough for virtual thing. So we can easily find the delay here. And if you go less than this 100, and it is hard to feel the delay, right? And if it is more than 100, you will find more delay, wasting of some time. No, so 100 will be best when you were practicing. Okay, so I'm going to run. So this is the noise signal. Okay, this is the noise signal, right? Whenever we go to any electronics laboratory, we can see if wire is connected, we'll get this one. If wire is not connected, again we'll get this one. Okay, so few people will be happy with this itself. They may think this is a sine wave only, but sharp sine wave, right? There are people who think like that. No, it will be funny while creating all this signal, right? So this is about a random signal with noise. And now I'm going to introduce one more interesting thing. So you can go with express, and you can go with input signal, right? And simulate signal. Okay, so I came with express, input signal, and simulate signal. Okay, I'm going to place this one. As I place this, I'll get one pop-up. Okay, so I got this pop-up. This is kind of a function generator, right? So inbuilt function generator, right? So we have sine wave here. Harini, can you mute your mic? Excuse me. Yeah, thank you. Okay, so now this is kind of inbuilt function generator where you can generate a sine wave and you can set the frequency, amplitude, right, and sampling frequency and number of samples you want to do, right, and you can even generate a square wave, you can generate triangle wave, and you can generate sawtooth wave and DC wave. Because you people, as a department of medical, you must know more about the signals. So you may be working with heart pulse, you may be working with so many sensors, heartbeat sensors, temperature sensors, oximeters, and ECG, EEG. So many things are available for particularly your department, right? So you must know more about the sensors as well as the signals, right? Which signal, how to take the peak values, threshold values, right? So now I will introduce the sine wave itself and see the frequency is 10.1. Okay, and here this is the sampling frequency. And as when you are involving into this, you must know what is Nyquist theorem, right? So what is Nyquist theorem? Sampling frequency must be greater than or equal to two times of message frequency. This greater than or equal to is an important sign. Then message frequency. So this is message frequency and this is sampling frequency, right? So why that Nyquist theorem is stating, what that Nyquist theorem is stating is that if your sampling frequency, okay, if you are taking a sample from the signal, if your sampling frequency is less than the message frequency, see, less than 10, this is not satisfying to reconstruct the original signal. Okay, so it is not possible. So if you give at least two times, that means 20.2. Now this is satisfying your Nyquist theorem. Okay, it is satisfying your Nyquist theorem. But see, it is not reconstructing the original signal. So that's why in Nyquist theorem, it must be equal to two times or greater than two times. So if you say greater than two times, so we'll get a signal like this. Again, this is not an accurate signal. Okay, so this is due to undersampling. Okay, so we call this undersampling as aliasing effect. So hope you might have heard about this, right? So we call this as aliasing effect. This is not reconstructing the original signal, right? Even if you go 10 times of the message signal, I mean 10 times means 100. Okay, so 10 times of message signal, again we are not getting the accurate reconstruction of original signal, right? So the better thing will be like as much as your samples is more, will you can reconstruct the original signal, right? So now it is trying to reconstruct its original signal, but as per Nyquist theorem, uh, the two times greater than, okay, so it must be greater than or equal to at least two times of message frequency is a general statement, but it must be at least 10 to 50 times, to reconstruct the original signal, right? So that clarity will be more and the resolution will be more. So it's more about the resolution and the clarity and the accuracy, right? So we just generated this sine wave. It is satisfying Nyquist theorem, and I'm giving OK, right? So now I'm going to connect it. I'm going to connect it. So guys, both indicators are same, right? So here we generated sine wave. Both the indicators are same, but why I use this, like, because of the difference in style. That's all. This is having black background. This is having white background, and you can see some difference here. Okay. So as you know about while loop, see, this will be keep on running until unless I press this stop button. Right? You can see still it will be running, 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 and running until I press this stop button. Right, I press stop button, stop. Okay, so now I want to view this as an exact sine wave, so I used graph help. You can right click here in visible items, you have so many things. X scroll is there, so you can go left and right and see all the values, right? And graph palette. So we use graph palette to zoom in, zoom out. So I'll click this and you can select a part of it and you can zoom it. Right. So here also you can just right click visible items, graph palette. If you want to zoom it, you can zoom it. If you want to zoom in, you can zoom in. Right. So here also you can see, like, scroll to see the values. Right. Now I'm going to run it. See, once you introduce loop concept, you no need to press this continuous run. Okay, because the loop itself is going to run continuously. Right. So never hit this continuous run once loop is introduced. It may be for loop or while loop. Okay, just hitting run button is enough. Right. And you can even customize this one. You can even customize your front panel. See, guys, the code is so simple. Just a direct connection here. So how to customize this front panel? So I'll go with the tools palette. Okay, so tools is here. So I'll tell one shortcut here: Shift plus right click. So this is your tools palette. Shift plus right click, and you can see some color boxes here. So you can choose the color. Okay, so you can choose the color. So any color. As you slide in this color, it will automatically change. Right? And even this border, you can change the border color. Right? You can change any color. So again, after changing the colors, okay, again after changing the color, see, the tool is not changing. Okay, the tool is not changing. Still, it is showing like a painting or paintbrush. Right. So what we have to do is, like, again after your setting is done. Okay, after your thing is done, you can just press shift right click again. Make sure this LED is on. You can make it on by clicking it directly. Okay, shift plus right click. Make sure this LED is on. Okay, and don't say just not work. Right, because this LED is automatic tool. Okay, so if you want to move some object from left to right, you need one tool. If you want to wire, you need one tool. If you want to type something, you need another tool. Right, if you want to paint, you need another tool. So instead of that, so if you enable this LED, automatically your tools will change. You no need to come and select here. Okay, so by default this LED will be on, right? And still you can customize this one, like, what else you can do? You can just right click and you can right click. You can change the button color. So now this is black. You can change the thickness. Okay. So as per your wish, as per your project, go with some dark colors and you can. Okay. And there are some plotting style. You can right click. You can see some plotting styles. I'll go with this one. I'll go with plotting style. This one. So I'll show some different plotting style. right? So as I run it now, okay, this is just a style. You can change to anything else, you know. You can even change as you change the width. Okay, so you can stop it here. Right. So likewise, you can generate any signal or any waveform or so assume again this is nothing but our sensor. Okay. So there is no difference between software program and hardware program. Both are same. Instead of this simulate signal, there will be one function where I mean I'll show that function. So there will be one data system function. You can download any PDF or anything or else you can check it. Right. So this right side program is same. This right side program is same. This left side you will just assign whether sensor is acquiring sensor or generating sensor. So if your sensor is giving input to the system, for example, your temperature sensor, heartbeat sensor. So all these are going to observe the environmental parameter and it's going to give the data to the system. So if any sensor is giving the data to the system, we call that as acquiring sensors or acquiring signals. Okay, so if your system is generating something, like you are controlling something, okay, if you are controlling some sensors or some motors and LEDs or something, if that is controlled by the system, that is generating sensor. Okay, so now temperature sensor is going to be like acquiring sensor, and temperature is going to be analog sensor, analog input sensor, and it is going to give temperature. So likewise, you can choose. Either you can measure the voltage of the temperature sensor or else you can directly measure the temperature of, right. So currently there is no device here. I have not connected any device here. But if it is connected, you will choose the device and you will choose the pin. Okay, there may be some 0 to 9 pins or 0 to 8 pins, you know. So you will choose which pin the sensor is connected. So that's it. You will select that and you can close that. And as you run the program, it will collect the data from that sensor and it will display that particular value. Right. It is as simple as that. Okay. So now I'll show some example programs. There are so many things you can do with this LabVIEW. Okay. With this limited time, we cannot do much more. You know. So there are so many interesting factors here. So you can work with robotics here. You can work with the communications here. You can work with the controls and simulations here. So in connectivity, you can work with so many things. You can interface with Python. So you can bring all the Python codes here, and you can work with database. So you can interface SQL with the LabVIEW, right? You can do ActiveX. Okay, you can use web service. You can publish some web service, right? You can do some advanced signal processing. Okay, you can do FPGA, and there are so many things you can do with this, and still more add-ons which is not installed in mine, right? And report generation, right? And you can work with any files, spreadsheets or notepads or anything. Okay, so that's what I was telling. You know, this is a single platform where you can solve many solutions. Okay, so this formula node is for C program. If you are good with C language, you can just drag, you can just simply give A equal to B plus C. So whatever C code you can give, you want to give, you can give. This comma is important. Okay, and we do have one more thing which is not in mind. Okay, so where you can put your MATLAB code. So you can just copy paste your MATLAB code and you can execute that one. Okay, so likewise you can also do with the Python, and you can also work with image processing. You can also do machine learning, right? Deep learning. So many factors are there, right? So I'll show some demos here. So this is a sample program, no, right? This is QR detection. So you might have seen QR code detection, right? So if camera is interfaced with this, if you show any QR code, so nowadays everything is right. If you go to any supermarket, everything is about the barcode and the QR code, right? If you use GPay or if you use phone pay, everything is about QR scan, right? So using, you can build your own LabVIEW application to scan the data from that. Okay, so now I will show one more thing, and this is about the color pattern matching. Okay, so I choose blue color here, right? It is identifying all the blue colors here, and you can set um, minimum score, right? Some accuracy you can set. If you want more accuracy or minimum accuracy, you can set, and you can get the values like how many number is matching. Okay, so you can identify the things. Okay, this. So as you change the template, again you can, it will detect the different things here. And another thing is OCR, optical character recognition. So we used to say this as number plate, you know. So camera identifying the number plate numbers and the owners and who bought this vehicle, you know. So you can even implement this in our day-to-day life traffic, you know. So many are crossing the traffic light, I mean not obeying the traffic signal, right? So no one is following the rules and all. No, you can set up a camera, it can automatically take a photo of it. And each and every vehicle owner should have a one online portal from government sector, so where their mistakes with the proof, photo proof, should be uploaded and they should be fined. And one call center must be set up, and which can give so many jobs for the people. So this call center will work by tracking these people. Okay, you have crossed this signal, this is the proof, this is your vehicle number, your penalty is this much, you have to pay it. If not, you will be filed a case. So likewise a system can be done, you know. It's already existing, but system can be done, you know. So you can speed up, you can speed up or you can delay. So whatever is scanned here is shown here, right, as a string format. This is image format, and what I'm highlighting is a string format. Okay, so it's extracting by reading the number. The system is understanding the language. So not only numbers, you can go with any translation. Okay, from Tamil to English translation, Telugu to English translation, or any translation. You can train the camera, and you can get anything as a string. Okay, so this can be done. And I will show something else in robotics part. Yeah. This is some basics in robotic. We can simulate the robotic part here, and the hardware is also same. This is about how we maintain the equilibrium. So ball along the beam. It you can, and you can even build some games here. So if it is a regular training, I'll show some games too. What we can implement here, right? So this is for just checking it. So what happens if the force is distributed like this, right? And next, so it's kind of a pendulum robot, you can say, a tooling pendulum with elbow. I mean, I said no, it's about robotics. So before checking how it exactly works, you can use all this code to analyze and simulate. You can see the simulations here, right? So this is about introduction. So pendulum robot, the pet name is Pendubot. Okay. So open loop, yeah. So now you can just simply move it. So you can analyze what is happening, how much force is generating, in which direction it is generating. So you can analyze everything. If you are designing a machine or if it is the robot, you can check all the parameters, right? So also the graphs. So this is what given in all the textbooks. If you read about any pendulum and uniform distribution of any force and all, now you can see this type of graphs. So this is not just a graph. This is generated from the moment of this arm. You know. So here also like it will swing up, right? So what if it is swinging up? So you can change set point to, right? And so both manual and automatic is available, right? And particular graphs are available, theta to angle. So what is the angle and control signals, right? So now this is steady. So you're getting a signal like this. So as I move it, the signal varies, right? So I'll show one more thing. So this is kind of deep learning program for object detection. So this is a real-time system again in the industry. If any of the product is like defected, how it is found? So using camera itself. So the product will be sent through the conveyor belt. So it can be any product, whether barcode is there or not, any damage is there or not, if it is a bottle, any hole is there in the bottle or leakage is there or not, whether cap is properly done or not, or any thread is missing or not. So all these are done by using cameras. Okay, so in the even in the medical field, everything, most of the testing pieces are using cameras, the images, right? So likewise, as any defects are there, you can automate it. It would reduce your time instead of taking one by one. See, per day they may generate crores of products, so everything cannot be taken and searched and tested, right? So this can be automated, and this will give you indicate the signal whether any defects are there, right? So if defects are there, you can take that and check it. If that is solvable, you can solve it. If it is unsolvable, you can just throw it, right? This is how it is used in robotic arm. Okay, so so many things are used. So whatever is the domain, LabVIEW is a single solution, and it's a single platform where many engineers, scientists, and the automation companies are using, right? So hope you got some good idea. Like we use the signal processing here, and next, as I said, image processing is a vital role here, right? And object tracking can be done. Okay, if you want to track any objects, so you can accurately do that. And so here I'm winding up my session, like I'm winding up with a quote called, don't just learn engineering, just do engineering. Okay, so let's start doing this engineering instead of studying the engineering. Don't never study the engineering, start doing the engineering. So whatever you learn from the subjects, it's not just to take the mark as CGP, or we are not here to get the placement, right? We are here, we are learning engineering to give the placements, right? You must be an entrepreneurs, you must be innovators, you must be a scientist. That is the main sake of learning engineering. It's not just to get a job. Okay, so don't limit yourself with some MNC jobs or this that and all. You should start innovating, start your own company with your ideas, be an entrepreneur. This is what we encourage from outside, right? So I would really like to thank the department once again, and the head of the department and the faculty coordinator once again for this wonderful session. And I think this is just a small eye-opening session for beginners, right? So hope this was helpful for you. Maybe we did a lot more things today, so it may be confusing, right? But you got clear idea that this is a pure engineering tool. So that's what the purpose of this webinar is, right? Really, thank you so much. everyone, right? So,
Thank
ma'am,
you very much, sir.
any feedback from your side?
It was very informative for the students, I guess. If any of you have any questions, you can post it in the chat box or you can also interact with the speaker.
Yeah. So, any questions, any doubts, or how you can learn further, or how you can join this, and what are all the courses available, what you can do with this? Okay.